This video provides a comprehensive overview of three popular prediction algorithms: support vector machines, SVM, k-nearest neighbor, KNN, and logistic regression, LR. Each algorithm has its strengths and weaknesses, and the choice of algorithm depends on the specific problem and the data at hand. Support vector machines, SVMs, aim to find a linear decision boundary that maximizes the margin between classes. The hyperplane is chosen to maximize the margin between the classes, making SVM a powerful algorithm for separating complex data. SVM can be used with both linear and nonlinear data and can handle high-dimensional datasets. Only support vectors are involved in determining the decision boundary, making SVMs efficient and noise-insensitive. However, SVM can be computationally expensive and requires careful tuning of parameters for optimal performance. To address the limitations of SVMs in handling nonlinear data, nonlinear support vector machines can be introduced. Nonlinear SVMs transform the data into a higher dimensional feature space using a kernel function. By doing so, they can handle complex relationships between variables and classify nonlinearly separable data. The choice of the appropriate kernel and interpreting models generated by nonlinear kernels can be challenging. Nonetheless, nonlinear SVMs offer enhanced flexibility and the ability to capture intricate patterns in the data. K-nearest neighbor, KNN, is a simple yet effective algorithm that is often used for classification problems. KNN involves finding the k closest data points to a new data point and using their values to predict the value of the new data point. KNN is easy to implement and can handle nonlinear data without requiring assumptions about the underlying distribution. However, KNN can be sensitive to the choice of k and can be computationally expensive for large datasets. Unlike other algorithms discussed, KNN does not construct an explicit target function or model. Instead, it stores training examples and classifies new examples based on their similarity to the k-nearest neighbors. KNN is advantageous due to its simplicity and lack of assumptions. Logistic regression, LR, involves modeling the probability of a binary outcome, for example, success or failure, using one or more input variables. The output of LR is a probability score between 0 and 1, which can be thresholded to make a binary prediction. Logistic regression is presented as an important classification method that estimates the probabilities of class membership. It introduces the logistic function, which maps the distance to the decision boundary to a probability between 0 and 1. Logistic regression is advantageous in its interpretability and its ability to provide probabilistic predictions.